Good afternoon. You're with Professor C again. We're doing linear systems in two variables, this time by the method of elimination, and we're on example number 2. In example number 2, we're going to have two equations. We're going to start with equation number 1, which is 4x minus 3y equals to 25. Equation number 2, we're going to have minus 3x plus 8y equals to 10. Notice that these two equations aren't going to be as straightforward as our first couple of examples, mainly because if we even tried to do substitution, that would be kind of difficult. We would have to isolate either a y or an x, and for example, isolating the y, we would end up with 25 over 3, or isolating the x in equation 2, we'd end up with 10 over negative 3. So it would be a bit of a process, doable, but more complicated. Elimination is a little more straightforward for us because all we have to do is try to find some kind of multiple of equation 1 with equation 2 that simply eliminates a variable. If you look, we can see, for example, 4 and minus 3. Well, the least common multiple between them is going to be 12. So if I was to take 3 times 4, for example, and 4 times minus 3, that would give me a pair that I could easily eliminate. So I would do something like maybe 3 times equation 1. So if I did 3 times equation 1, I would have 12x. But remember, I have to do the 4x by 3, then minus 3y by 3, so that would be minus 9y, and the 25 by 3. That's going to be 75. I'm going to have to follow that up with 4 times equation 2. 4 times equation 2, so 4 times negative 3x is negative 12x. 4 times the 8 is going to be plus 32y, and then the 4 times the 10 is going to give me the 40. That's not terrible, but it is a little more complicated than the previous example. Certainly the x eliminates, so that's great. I have 0x, I'm not even going to write it. I have 32 minus 9, that's 23y. That's a little awkward, but let's see what we have on the right. 75 and 40, that's 115. Actually, that's going to be kind of nice, because if now I decide to divide both sides by 23, I see that I'll have y is equal to 5. And that's going to be a wonderful value to move forward with in one of the other equations. So I'll take, for example, equation number 1 that I started with, and I'm simply going to take the value I got for y, so I'll have 4x minus 3, I had 5 for y equals to 25, so I'll get 4x minus 15 equals to 25. Can add 15 to both sides. Add 15 to both sides here. I will have 4x equals to 40. Divide both sides by 4. X is equal to 10. So I've got that nice. That gives me a value for x. Well, that means if I write the pair of values that I got, the x will be the 10, the y part will be the 5. So I'm claiming that 10, 5 is going to satisfy both equations. So I found that value last by putting it into equation 2 here. So I better check it with equation 1. So I'll rewrite equation 1 here. Equation 1 was 4x minus 3y equals to 25. So if I check the x is 10, 4 times 10, that's 40, and then minus 3 times 5, that is 15, and I work that out. Yes, that is indeed equal to 25. So I'm confident that that is a solution that satisfies both equations. So I'm going to make a nice big box, make sure my answer is obvious, and that's complete.